Okay everyone, so here is my video on how to use Slicer and how to slice your models. And this is very important because after you after you upgrade your printer and get it all working correctly, then the next step is to make sure you're slicing your models the best way possible, because that has a huge impact on the model itself when it's printed. So I'm going to go over a few basic things first. As you can tell, I did eventually find a screen recorder that works. These little watermarks in the corner over here. You can see it's the BSR screen recorder. I'm using their free version, which actually with the Xvid codec works really nice, so I'll give a shout out to them. They actually provide a nice screen recorder with a lot of frame rate and codec settings for nothing. All the other options either look like crap, or they would limit your file sizes, the length of the files, the quality, or they would have a big ass watermark covering half the monitor up here at the top. So anyway, let's just get started here. So first, I'm going to show you just simple terms that you'll understand what we're talking about the rest of the video. This is the model sliced right here, but it's only the bottom section, the very bottom part of the slice file, so I can show you what I'm talking about. This right here, this outer line here that's going around the model, notice there's 3 of them. This outer line is called an external perimeter, and the other 2 lines on the inside of that are just called perimeters. Same thing here with this hole. This is the external one, the outermost one, and the 2 inside are just perimeters. So you've got an external perimeter, and then you have 2 more perimeters inside of that. These lines going crisscross in here are what's called infill, and specifically they're called solid infill because there's no gaps. This area around the whole model here is called a skirt. It just puts down a couple beads of plastic to make sure the extruder is actually extruding plastic before it moves over here and starts printing your model, because sometimes it'll go to start printing out here before the plastic's actually coming out. And yeah, that's pretty much it. I'm going to turn on the travel moves. These little cyan blue lines going across the model are the movements that the printer is going to make while it's not printing. So for example, if it moved from here across this cyan line over to here, that means it needs to just transfer to go print this port over here. It's not going to be printing between those points, so that's called a transfer move. We're going to look at that later, so let's get right into it now. This is just the carriage, the XZ carriage model that I actually printed for the printer, and this is just a standard cube over here, which I'm going to show you how to calibrate your printer first with that, because it's very important. Everything we're talking about will rely on your calibration being right. So we're going to go straight here to configure in a second. Make sure that you have the profile here selected that you want for your printer, or sorry, for your filament, for your printer, and sorry, this is the filament here. This is your general slicing settings, and this is your printer settings. They don't have them named very intuitively over on the left here, but anyway. So when you click configure, it's going to pull up the configuration panel. And here's where all your settings that control the slicing happen. So we're just going to go in order here. One quick note, if you change something in here, no matter what I'm talking about, and you don't click this little blue save disk button, when you go back here to slice your model, it's going to slice it with whatever settings it was before you changed it. So always remember when you close this settings panel to click this first, otherwise nothing's going to change that you changed in the process. So right here at the top, print settings, this is your settings for the printer, the main slicing settings. The filament settings, this is pretty much pertaining only to the filament itself, and these settings are only for the printer itself, more or less, which means print bed size, speed, and stuff like that. In here, this is where you're going to set your nozzle diameter to 0.4 in my case, 0.4 millimeters. This retraction panel right here, kind of important. Normally the retraction is 1 to 3. I found to be a good value for PLA. I have it set to 2 millimeters right now. Lift Z, this means that every time a retraction is triggered, it's going to lift your print head up. But that's a bad thing because, or it's a bad thing in general, because it's going to constantly go up and down as it moves around the model. And a retraction is basically triggered whenever a travel move happens. So remember I showed you earlier those cyan lines that cross the model. Every time it moves from A to B without printing, it's going to retract this amount, 2 millimeters, to make sure it doesn't drip or leave a blob when it ends up where it's going. The speed is how fast it's going to move from there, how fast the travel moves are made, 90 millimeters a second. Or sorry, this is the speed that the filament is retracted. And down here, this is the minimum amount of travel it has to move before it will trigger a retraction. So in other words, if the nozzle only moves 2 millimeters or less, which is a really short distance, it won't actually retract because it's not necessary. Retract on layer change. This causes a retraction every time the height of the Z carriage changes. So for example, if it goes from layer 50 to 51, when it starts layer 51, it's going to do a retraction. And the only time you need this on, which I have on right now, is when you're printing something with a perimeter that's more or less symmetrical or continuous, such as a sphere or a cylinder, because what will happen is when the nozzle comes around and it stops, when the printer goes to move up to the next layer, that millisecond it takes to move up allows extra plastic to ooze out, and you'll end up with a slight ridge on the side of your model. So I have it turned on at the moment because I was printing something like that. Wipe while retracting here. This wipes the nozzle across the model as it's doing this retraction so that you don't end up with a blob anywhere. And the retraction down here, this is disabled. This is for multi-extruders, so we'll just ignore that. This custom G-code, just custom stuff that'll be applied to every G-code you generate with this settings up here. And that's pretty much it. Filament settings, this is one of the more important settings. Make sure that when you open this, when you go over here and click configure, make sure that this right here, right now you can see I have Fox 1.75 PLA. Make sure that's actually what you have selected up here, because sometimes if you were editing something else, such as this one, the Biophyla Silk, if you come in here and start changing all these values and you don't check this first, this doesn't always match this over here. You have to make sure they match. A little bit of an inconvenience, but always make sure you're looking at the right setting. This is the diameter of the filament. You need to measure this diameter with a micrometer on every spool of filament you buy, even if it's from the same manufacturer, because it varies. This is your first layer temperature, your other layer temperature. I have it set to 220, which seems to work great for PLA. And then the rest of my layers, other than layer number 1, is 218, a little bit cooler. This extrusion multiplier here is important. I'll show you in a second how to use that. So basically the first thing we'll go over is calibration really quick. The way to calibrate your printer is to make sure that you're actually extruding the right amount of plastic out of the head. Simply putting in the correct diameter for the filament itself doesn't actually ensure that you're printing the correct width edges and models, because apparently the viscosity of the plastic varies by batch and by manufacturer. So just because the diameter is right doesn't mean the right amount of plastic will come out of the nozzle. So what you're going to do to calibrate your printer is you're just going to take a cube, a standard cube like this. This is 1 centimeter square. You're going to go into your configuration, which I already have open. You're going to go to the print settings. You're going to set this vertical shells here to be 2. My layer height is 0.2. This doesn't affect what we're doing right now that much. You're going to make sure that the bottom set to 0 and the top set to 0. You can set the bottom to 1 or 2 if you want. It'll just put a base on it, a solid base. And then in here in the Advanced tab, you're going to make sure that the default extrusion width is 0.5, first layer 0.5, perimeter 0.5, and external perimeter is 0.5. And since we told it that we wanted to print 2 vertical shells, 2 shells at 0.5 will end up exactly 1 millimeter. So we'll go ahead and slice with those settings. Now notice I have to click Save here. So we're going to slice the model. And I'm going to show you something else really quick here. When it pulls up this G-code panel down here, if you check off Show Layer Range, this allows you to basically show only a range of layers. Looks like I made a boo-boo in here. We'll go change this really quick. I set the top to be solid instead of the bottom. And I also have the infill turned on at the moment. Okay, so the bottom's 2 layers, top is 0. I'm going to turn the infill off for the moment so we can see how to calibrate, because you don't need that. It's thinking here. Okay, so now you can see my box has 2 layers on the base that are solid. You don't have to do that. And then notice the 2 perimeters that make up the vertical shell of this cube. and they're going to go all the way to the top of the cube and then stop, and there's not going to be any top on it because we want to be able to get a caliper in here and measure this, or a micrometer in here and measure this width. So basically you're going to do this process right here. You're going to go ahead and print it, and then you're going to take your micrometers or your calipers and you're going to measure right here at the very top edge. You take your model off the printer. You only want to measure the first 2 or 3 layers there at the top. You don't want to go down into here because flaws can make the readings come out wrong. So grab a little tiny section here on the top and measure it and make sure that it's exactly 1. If it's not exactly 1 millimeter, you know you're extruding either too much plastic or too little, and we're going to go see how to change that right now. So we'll go back to the slicer settings. And let's say that I measured my cube, the wall thickness, and it came out to 0.93 instead of 1. So what we're going to do is we're going to pull up a calculator. We're going to say 1, which is the value we wanted the width to be. We're going to divide that by 0.93, which is the actual width of the model we printed, or the walls. And what we get is 1.075. So if we just ignore this part and round it off, in our extrusion multiplier here in the filament settings, we would enter 1.075, and then we're going to print another cube, and what we just did was we told it to print a little bit, to extrude a little bit more plastic than the default 1, and it should now end up exactly 1 millimeter when we measure it. If it doesn't, just repeat the same process again. I've only needed to do this once, and as long as you use the calculator, it seems to come out perfect the next time. So anyway, there you go for that. That's how to do your calibration. Make sure you're actually getting the right width, perimeters, and extrusions. That's very important. I'm going to go ahead and pause this and resume it. Okay, so here we are again. Now we're going to go over all the settings and how they affect your print. Now that you've got your printer calibrated, you're going to go back in the configuration. We're going to go over each one of these as quick as I can, because the last time I tried to do this it took an hour. So right away, layers and perimeters. These are just what it says, layers and perimeters of the model that you're slicing. Layer height, this is how thick each horizontal layer is going to be. 0.2 is pretty nice. 0.1 is going to be really extra fine. 0.3, 0.4 if you're printing something really big and you're in a hurry. First layer height's 0.3. It's a little bit thicker on purpose because you want to extrude a little extra plastic the first time around to make it stick better. I'll show you something else later for that. Vertical shells, we already went over that. The perimeters that we printed was 2. This is how many vertical shells or perimeters are used for the vertical parts of the model. A good value for this, if it's 0.5 millimeters, is 3, because that gives you a wall thickness of 1.5 millimeters, which is actually pretty strong as long as you have some infill. Spiral vase is only for certain kinds of objects, so we'll ignore that. Horizontal shells, now this determines how many layers are put on the horizontal surfaces. So if we downsize this a little bit so it's not so massive, and I show you what that means. This surface right here is a horizontal surface, same as this one here. So when it's printing those surfaces, which also include the top and bottom of the model, it's going to use these values. Now remember, our vertical shells are a total thickness of 1.5 millimeters. If we want the horizontal to be close to that, so the strength is relatively the same, but it doesn't have to be exactly the same. So what we're going to do is set this to 5, and the reason I'm setting this to 5 is because 5 times your layer height, 0.2, will give me a value of 1, which is 1 millimeter thick. So I'm going to have vertical shells that are 1.5 millimeters thick, and horizontal parts will be printed 1 millimeter thick, which is plenty thick in most cases. Okay, right here, extra perimeters if needed. Basically puts more perimeters if it determines that you're on a sloping surface and something's going to droop and fall down. Avoid crossing perimeters. Just basically avoids crossing the perimeters, just like it says, so that the nozzle doesn't leave marks or drops of plastic on the perimeters that show up later and make it look ugly. Detect thin walls. Looks for walls that are too thin and leaves a gap there instead of trying to print something. Might want to turn that off. Detect bridging perimeters. Bridging happens when the nozzle goes across something that's not supported and it's a short distance. So let's say something's 2 or 3 millimeters, and then on the other side, I'm going to show you right here. Let's say this in here is considered a bridge by the slicer program. when it's going to print across here, if it detects that it's a bridge, it's going to speed up and print across there really quick to help the plastic freeze in midair and not drop down here and end up in the middle of nowhere, and then make a big saggy mess. So we'll go back to our settings here. Seam position, this is where the seams are going to be in your model, which means where it resets every time a layer ends. So when it finishes layer 1 and goes to layer 2, this seam position is going to determine where the nozzle goes to start the next layer. Right now I have it set to nearest because it avoids crossing a whole bunch of parts of the model and possibly catching on them. External parameters first, we'll go over that in a second. Sometimes you can put this to aligned. So let's say I was printing a sphere. If I leave it on random, it's going to randomly start in a new position every layer, which will help there not be a visible seam in your model, which sometimes is a good thing. But if we have it on random and we're printing something complicated like I am right now, that means the nozzle is going to zip all over the place and possibly hit something and crack it loose while it's printing, and that's not a good thing. So most of the time you'd probably want it on aligned or nearest. Random is those cases when the object is really symmetrical and you just want to randomize the start point so you don't end up with a line or a seam in your model. External perimeters first is very important here. We'll go over that later. I have it turned on at the moment. Okay, so infill. This fill density is basically the percentage of infill that it's going to put in the model. This is your fill pattern, honeycomb. Top and bottom fill pattern is rectilinear, which are the lines we looked at earlier when I showed you the solid infill. Combined infill every 1 layers. This is going to, if we set this to 3, it's going to skip the infill on layers 1 and 2, and when it gets to layer 3, it's going to attempt to print enough plastic to fill in and make up for all those lost layers of infill. This can be a good thing if you're in a hurry and you don't care if it's that strong, but I leave it at 1 because that prints infill for every layer that you print. Make sure everything's connected. Solid infill every 0 layers. If you set this to, let me show you something really quick. I'm going to go ahead and save this and reslice the model with the infill turned on. Just want to show you what this does. Okay, so when we're looking at the model, this honeycomb in here is the pattern we selected at 15%. That's our infill. And if we pull this down so it's easier to see what we're talking about, the solid infill is below it as the start of the model. Remember, we specified we wanted 5 layers, so it printed 5 layers of solid, and it switches to honeycomb. Now when we go into the settings, solid infill every how many layers? If you set this to 10 layers, every 10 layers of honeycomb, it's going to switch and print 1 layer of solid to help strengthen the model and make it stronger. I haven't found it to be necessary. Fill angle, not sure exactly what this does, haven't seen it change anything. The solid infill threshold area is going to determine how small in square millimeters an area has to be in order to change it from this honeycomb up here to solid so that the print head doesn't move around in tiny spaces really fast, number 1. And number 2, so that those tiny areas are stronger. So let me show you an example of that, 50 square millimeters. So as we scroll through the layers here of our model that's sliced, notice right here, trying to get this to show up. Okay, it's not actually going to show up on this one. I need to go change this and raise it up. Let me just set this to about 100 for something to show up here. Hopefully this will do something for us so I can show you. Okay, this is a good example finally. So see this area right here in this little wall right here between these 2 perimeters. Notice it's putting a solid infill right here. And if we scroll down, you notice it disappears and becomes the honeycomb at some point. It becomes solid and it goes back to a honeycomb. Now right here where it becomes solid, this area in here was less than 100 square millimeters, which is what we keyed in, and therefore it's solid infill. So this is useful in controlling what's solid and what's not in your infill, because it's going to put both in there. It's going to use a combination of this percentage with this pattern and solid with this area. Only retract when crossing perimeters. This means that while it's doing the infill phase, it's not going to retract if it goes from here to here, because it's not crossing a perimeter. Now if it was to go from this point here over here, it's going to cross this perimeter right here, and therefore it's going to retract to make sure it doesn't leave a mark on your model that's visible. Infill before perimeters just generates the normal way for it to print, or the order for it to print, is to do the perimeters first, these outside perimeters, and then to do the infill. So if you want to reverse that and print the infill first, that's what that checkbox does. Okay, skirt and brim. Remember I explained earlier this area that goes around the model here was the skirt. All that does, you can set here how many loops you want it to do, the distance away from the object it is, the height of it in layers. I only need one layer because all I'm doing is making sure the plastic's starting, and that just gets the plastic going and makes sure everything's working. The brim width here is the exact same thing, but this is connected to the model. So if we were to turn this on and set it to 3 millimeters, it would print something exactly like this. It's connected to the model here at the base, and what that does is that makes sure that your model does not come loose from the print bed while it's printing. And this is important when you're printing on a cold bed like blue masking tape. This part I actually printed on a cold bed, and as I stated in my last video where I showed it, it actually did warp and come loose from the bed a little bit, but the part ended up being usable anyway. If you print on a heated bed, you won't need this. So if you're printing big parts like this, and you're printing them on a cold bed, make sure and turn the brim on so that it doesn't come loose, and set it to something wide like 5 or 6 millimeters. We're going to go on now to support material. The support material is the material that's printed to support overhangs and things that are not going to be supported by something else on the model. So if we scroll up here through the model, this right here, this honeycomb structure right here that you see, this is a support structure. This is not actually part of the model itself. And when we scroll up here, we can see what it's supporting. It's supporting this big section up here. This is the actual model. It comes up here at an angle and then comes out straight, but it's in midair. So if it attempted to print this with no support, all this plastic would just droop down and end up in the middle of nowhere. So this support ensures that it's actually supported. And that's what we're going to go over right now. Generate support material, I have it turned on. This is an overhang threshold in degrees if you want to make it turn on after a certain degrees. I haven't found it to be necessary. If you leave it on automatic, which is 0, it seems to work great. Enforce support for the first how many layers. If you set this to, let's say 10, it's going to manually turn on the support for the first 10 layers, regardless of whether anything needs it. And then after that, it's going to automatically determine whether or not something needs support. Raft layers. Raft generates a crisscross under the entire model. This was used in the old days apparently because ABS parts and apparently some PLA would come loose and warp from the bed before they had heated beds. So you don't really need this normally. Here's the main options for the support material in raft. So contact Z distance, 0.2 millimeters detachable. That is how far, we're going to close this again. That is how far this surface right here, see these little zigzags right here? That's how far, see how there's a gap between them and the model? That's the 0.2 millimeters right there. That prevents it from attaching too well to the model, because later on when you go to snap it off and remove it, you don't want it welded on there. The pattern we have set to honeycomb. The default is pillars. I don't like pillars because you end up with a bunch of little pillars, and if your nozzle hits one of them while it's printing, or 2 or 3, at some point, it'll snap them, and once they're broken and leaning, they don't work anymore. So I like honeycomb because everything's connected, and it also means there's less travel move, so your printer has less vibration, because instead of the head moving from pillar A, B, C, D, it just stays on one pattern for the honeycomb. Pattern spacing, 4 millimeters. That is the spacing right here in between the honeycomb patterns. So from here to here is roughly 4 millimeters, the spacing in here. So that determines how tight or loose the pattern is. You don't need extra plastic being wasted. Pattern angle doesn't do much. Interface layers 4. And interface pattern spacing is 1 millimeter. I'm going to show you what these two values do right now. Interface layers and interface pattern spacing. So when we go up here to where it's actually supporting the model, this right here is the interface layers. Notice there's 1, 2, 3, 4 high, and the spacing between this line and this line and this line each time is 1 millimeter. So that is your spacing width. Notice here 4 interface layers and a spacing of 1 millimeter. Alright, now we're going to go on to the speed. Most of the time printing at 30 millimeters a second with PLA at least works great. This 90% here means that your external parameters, or the last parameter, remember I told you earlier, on the outside of the model, is printed a little bit slower. This doesn't have to be like this, but it is by default. Infill is 40 millimeters a second, so you notice this is going to be printing faster than the perimeters, because it's not something that's really going to be visible. And down here, support material interface, so supports are going to be printed at 70% of the default speed, which is 30. So 70 millimeters a second is a little slower for the supports. You can change that too. And all these can be keyed in either as a direct value like this, as 40, or a percentage, and the percentage is usually calculated over something else, and you can see in the tooltips what that is. Bridges is 50, so when it bridges A to B with no support, it's going to do it a little faster than a regular print move at 30 because it doesn't want it to droop down and sag. And then gap filling. Okay, so travel, this is the speed that the printer is going to move from A to B. Remember I showed you travel moves earlier? 130 millimeters a second seems to work great. You want it to move fairly quick without jerking the printer too badly, because the faster it moves, the less chance there is for blobs. First layer speed, 80 millimeters a second. Now you notice this is set to a percentage, so it's not moving 80 millimeters a second, it's 80% of the default print speed, which is 30. So the first layer is printed slower to help it contact and stick to the bed better. Just ignore this section here, and I'm not sure what this is down here. Oh, this is the max print speed and the max volumetric speed, so never needed those. Multiple extruders, you can ignore that because in my case the printer only has one extruder. Output options doesn't really do much here. Few little things that you want to turn on, verbose, flagging, and stuff like that. Notes, this enables you to put notes in here about your profiles, because if you change something in here, click save, and then put in a different name to create a new profile, you can put notes in here to help you remember what the profile does. So now we're going to go to the advanced tab, which is one of the most important. Your default extrusion width here is just what it says. The default width is going to extrude at the first layer, 0.5. Sometimes this value is higher by default, which means that on that first layer, remember earlier I showed you in the layer and parameters. I'm going to pause this. Okay, so I'm back again. So remember earlier I showed you the first layer height was 0.3, a little thicker than the other layers, and the reason for that is by default in here, the first layer, this will not be 0.5. By default, this is something else. It prints a little bit thicker, wider bead of plastic to help it adhere to the bed. At the moment, I'm printing molds, and I don't want to have to shave it off later, so I have it set to exactly 0.5 so that the perimeters are the same width, and I don't have to shave off a lip on my models. This is the width of your perimeters here, 0.5 millimeters. And then the external perimeters, which I explained at the start of the video, same thing, 0.5. And I found that it's usually best to keep the external perimeters and the inside perimeters the same. Doesn't mean you have to, but it seems to make the most uniform shells or models. The infill width here, solid infill, top solid infill, and support material. I just leave them all 0 for default. If you want to print something, let's say the infill's not sticking well enough, you can come in here and bump this up and make them a little fatter and wider so that they adhere better to each other. Whatever you want to do. This is the infill perimeter overlap. This is how much, I'm going to show you right now, that your infill overlaps the perimeter. That's exactly what it says. Go down here. Whoops. Forgot the mouse wheel here. It just says. Okay, so this honeycomb perimeter right here, when it comes up and intersects the perimeter, it's going to overlap by 15% to help it stick or bond with the wall. And the same with the solid here. When it does these solid lines in the bottom, when they intersect the perimeter, it's going to overlap by 15%. So if you find that it's not sticking well enough or your infill is breaking off from the walls, which I've never found to be the case. You can bump this up to 20, 25%, whatever you want. Bridge flow ratio, just ignore that. That basically makes the plastic flow faster or slower when it's jumping across a gap, like I explained earlier. XY size compensation, this, it says here the object will be grown shrunk on the XY plane by the configured value, negative inward, positive outward. This might be useful for fine-tuning hole sizes. Now, this is the wrong way to compensate for a hole, especially an inside hole, being too small. This is putting a band-aid on a broken arm. That's not the way to fix it. I'm going to show you right now the optimum settings and why I use them. So I'm going to go ahead and pause it, and then we'll get right to that. Okay, so the most important thing when you're printing your model is to make sure, after you set up all your perimeters and the thicknesses and how many you want and how much infill you want and all that jazz, you need to make sure, especially if it's a model like this where you have internal holes for this bolt, for this bearing holder, this bearing shroud right here, you want to make sure that these holes come out the right diameter. Because if they don't, your bearing's not going to fit at all. And this one has a gap in it so it can be flexed a little bit, but in most cases like this one over here, there is no margin of error, so if it's too small, there's a chance that things won't fit at all, and then you'll have to be getting out drill bits and making a mess. So first things first, the first thing you want to do is make sure that you have this option checked off right here in the layers and perimeters. External perimeters first. You want this on because when you're printing the perimeters out here, when the printer's going through the perimeter layers, you want to print with the outer layer first, and the reason for that I'm going to show right now with this little illustration. Pardon my bad drawing. This is what happens when the plastic comes out the extruder nozzle. It comes down here, squeezes out. This nozzle is 0.5 or 0.4 millimeters wide on my printer, and notice I put 0.5 millimeter up here as the width that we're extruding right now. So when it extrudes to 0.5, it squeezes out a little bit on either side of that extruder orifice or hole to the 0.5 width. And when you blow that up, it looks something like this right here. That edge of plastic is not square. It doesn't come out in a sharp corner and come down. It squeezes out in a round profile. And what that means is when it comes along to do the next perimeter next to it, because remember we have it set to 3, this green one, number 2, is going to overlap. Notice the overlap here of those two round edges, and when it does overlap, that means your extra plastic has to go somewhere, and this flat area of the nozzle is making sure it doesn't go up. So the extra plastic is going to be pushed out to the right here, and your center, which should have been right here, is now going to move over. And by the time you do the third layer over here, that overlaps layer or perimeter number 2, when you do perimeter number 3 out here, this one's going to be shifted over quite a bit from where it should have been originally because of the shape of the extrusions. And if this perimeter here, the black one, is number 1, and it's the external perimeters, everything's good to go, because that perimeter is going to be in place, and these ones, the internal ones, are going to move inward as they shift. But if you didn't have that turned on, if you had this turned off, like this, when you're printing, what's going to happen? It's going to print this internal perimeter right here, this middle line first, and it's going to do number 2 here, and number 3 will be the last perimeter, which will be the outside one. And so instead of the inside layer shifting inward, it's going to shift the outer perimeter out, which will make this hole too small inside. So very important, turn on external perimeters first if you have parts that interlock, parts that have internal holes, anything like that, turn that on. And another reason to turn that on is, remember the overlap we discussed earlier between the infill and the perimeters, that 15% overlap when it comes up here and overlaps? I have found that the infill, especially the honeycomb, what can actually happen is when it comes up here and intersects, even 5 or 10%, that little bit of extra plastic sticking in there, if you're printing the infill first, which remember was an option earlier, if we print the infill first, I'm going to show you that right now. It is right here in the infill. Infill before perimeters. If you turn this on, what can happen is the same thing. This plastic is going to be pushed over here before it prints these perimeters here, because we're printing the infill first, and then when the perimeter comes along to print, guess what? It gets shifted over by that plastic as well, so you're going to have little tiny ridges everywhere one of these lines intersects because that extra plastic is pushing the perimeters out. Now if you have external on, external perimeters first, it's going to minimize that because even though it's overlapping the internal one, the external one's going to be placed down first and semi-cool so it can't move. Then it's going to print 2 and 3 inward, and you won't really notice it that much, but it will still be there. So I found the second best thing to do, or the second best advice I can give on printing is make sure you print the perimeters first. That way you don't have issues because the perimeters are already laid before the infill intersects it, and it can't cause any problems with the outside of the model. Let me pull up that illustration one more time. Just wanted to show really quick here. This is a 0.7 millimeter width for the extrusion. The nozzle is still 0.4 millimeters, and notice how the width of this comes out further than it would have if it had been a 0.5 over here. Just kind of showing if you get this number too crazy high in relation to your nozzle width, which mine's 0.4, I would say make sure it's less than double the nozzle width. So for example, if my nozzle width is 0.4, you want to be less than 0.8 millimeters, which is double, or things get a bit wonky and you'll start to see flaws in your perimeters. Make sure it's 0.7. A nice range for a 0.4 nozzle seems to be between 0.5 and 0.7. 0.6 prints really beautiful, 0.5 prints beautiful. Just quick tip. Okay, so back to the settings now. So the last thing I wanted to show, we went over the main stuff already, is just these settings here for the layer ranges. This, obviously I showed you earlier, just check it off. This allows you to scroll through the layers from 0 up. If I change this first slider, it starts at that layer and then goes up from there. So I can cut off layers below. This only shows a certain layer, so in other words, if I zoom back here, I'm only going to see the layer that I'm scrolling through, not everything else, which is kind of nice if you want to see a certain layer without everything else. And normally it's defaulted to show completed code, so it's kind of hard to see what's going on. So I almost immediately check this off, and then go in here and scroll through the layers to make sure things are being infilled correctly like I want. Manual control over here. These home buttons respectively home each of the 3 axes by themselves. If you click this one, they all go to their home position at once. And of course the arrows allow you to move everything around. If you want to move something on the printer by hand, just click this turn motor off button, which turns the motor off so you can move it by hand. Heat extruder does exactly what it says. Heat print bed, once again, doesn't need to be explained. These temperatures are all in Celsius, so make sure you put the right number in Celsius in, not Fahrenheit. Extrude here allows you to manually extrude filament to make sure it's flowing correctly, like when you load a new filament in or it breaks off or whatever. Just make sure you heat the nozzle up first, because if you don't, your extruder body is going to be sitting there grinding away on some cold filament. Retraction, if you want to manually retract the filament for some reason, you can retract it. Okay, the one last thing I wanted to show before I sign out here is make sure when you're printing small walls, I'm going to show you right now what I'm talking about. When you're printing perimeters such as this one on the bearing shroud, notice that we have 1, 2, 3 perimeters, and then the same on this side, 1, 2, 3, and they both share the center one, of course. Make sure that you have the perimeter set high enough to not leave a gap in here. If we were to go back into the settings and change it to 2, what would happen is there'd be a gap in here, and the printer will decide to come in here and do a solid infill with little zigzags, and that's going to make your printer jitter all over the place and vibrate every nut and bolt loose. So make sure that you, when you have tight areas like that should be solid anyway, just bump the perimeter values up so that you don't end up with solid infill being placed in there, because it's going to cause a disaster during the print time. This will be a much cleaner print anyway, and you could speed the printer up on this model and not have anything to worry about. If you have little short zigzag moves down here and something, look out, your printer's going to be falling apart. So that's pretty much it. Make sure and calibrate your printer. Hope you guys have fun. Obviously I only went over the slicer settings. I have not gotten a chance yet to use the SkeenForge or SkeenForge, however you say this. I haven't needed to use it. I found that once I learn to use slicer correctly, I get beautiful prints, especially now that I have my printer modified. So that's pretty much it, guys. Hope you like it. Hit the like button if you do, and subscribe for more videos. Thanks, guys.